Hello explorers and welcome to another video. Today I'm gonna try to solve the day 2 puzzles of the Advent of Code Challenge 2018. So we're gonna continue with day 2 now, and day 2 I have actually read the description this time. So I'm a little bit prepared. As you hear, my voice is not really up to par, and I had another video planned, but I will do this instead because of, I can't really make a good video with good sound with this voice. So I hope that you think it's fine anyway, even though I'm a little bit raspy. So this challenge that we have today, we are going to find a checksum, and a checksum for some packages, and their ID is a number of letters. I guess there are 6 letters in each box ID, and we will find a checksum by counting how many times 2 letters appear that are equal and how many times 3 letters appear that are equal. So for instance, in the first here, everything is different. So no one of them it appears 2 or 3 times. The second, A appears 2 times and B appears 3 times. So it counts for both. So this will count 1 plus 1. And then so on and so forth. And at the end here, that have counted that 4 of them contains pairs, and 3 of them actually contains triplets. But it only counts once per ID. So we have one row here where you have 2 A's and 2 D's. So that only counts once. So we will need to find those box IDs which have 2 letters and 3 letters that are the same, but we can only count that once. So we will look for triplets, look for duplicates, but for each box ID we will only count this specific combination once. So if we are thinking of it in terms of cards, in cards you can have a tris, or 3 cards of the same color, or 3 cards with the same number. So you can have 3 fours, or you can have 2 fours. So you either have a pair or you have a triplet. And even though you have 2 pairs, sometimes that will only counts as you have the pair. But if you actually have a full, no, not a full house. Is that the name in English? In Swedish you call it kåk, and then you have one pair and 1 three. So let's try to do some code. I've talked enough about this. So in order to figure this out, first of all we need the input here. So this is all the inputs. And we will save that as day 2. 2 input. Maybe we'll have to call it txt as well. Maybe that would be a duplicate. We will see. No, it actually was day 2 input. So, in order to do this, we need to figure out what kind of letters we have. And if I look at this, it seems that all letters are lowercase. So that could be something. So let's say that we make an array of 25 positions. So we say like this, characters, chars. So we'll do an int array. Int is probably so very much overkill. We could have a byte as well, but we are not actually memory constrained here. So we do an int 25, and it should be an array on both sides, like that. And if we are lazy, we could just check for the index in the string. You could actually just remove, I think, 65 from the number of the char, and you will get the index. But I'm lazy, so alpha Beth. Write it like that. And this is A, B, C, D, E, F, G, H, I, J, I guess. And KLM, O, N, O, P, Q, R, S, T, U, V, W, Y, Z, X. We need to have that as well. Could that be 25 letters? Or don't I remember the alphabet? It's actually 26 letters. Okay, so let's go for 26 then. Like that. And then we will need to go through this. So we can copy from day one. Let's just bring in the read code here. Just to simplify things, we don't have to write this again. So if you are wondering what's going on with this read code, look at the first day's problem and you will get how this code works. I will not talk about this code again. And as we're doing things quick and dirty, we will just have a catch here that throws an exception, perhaps, and we will print that out if it happens, just so we know what happened. And now we have a line. So for each of this line, we need to go through it, and we need to look at each character of the line. So I wonder if you can do a char C in a line because of the stringiness. No, we can't. We can do get bytes, get chars. Why do we need source end? And a char. That was a bit weird. Destination, begin. And then we need to know the actual length of the line. Nah. Do we have a length? We have a length. So maybe we can do just like this. Because it's simple ASCII, we don't need to actually handle Unicode and look at code points as you do when you do Unicode, because then you can have multiple chars. Two chars can be one specific letter, for instance, or if you have a 16 alphabet, then you need 4 chars, I believe, to show one letter, depending on how the Unicode actually works. So on this line, can we do like this? No, we get char at, I believe the name is. Yeah, char at I. So then we will get char. So that's the thing we want to look at, and then we will take the alphabet and we will check index of that char in the alphabet, and that index, we will take the char's position of that index and we will increment it. So now we will look at this line and we will create an index increment where we will actually fill this up. And I believe there also is an array fill. So you can fill chars with 0, for instance. So we know that it actually start with 0, and then we will increment it. And now when we have done that, we need to look through this and see if we have the number 2 anywhere or the number 3 anywhere in this chars array. So we will go through it again. And this time I think we can just do an int char. Char is not a good name for it because that's very much a restricted word in Java. So now we have C, and that's actually number of instances in the string. And if it's this number of instances is equal to 2, then we will do something. And if number of instances is 3, then we'll do something. And we can be very naughty and just create 2 booleans. So we can say we have a double instance, and that's false to start with. And then we have a triplet instance, and that's also false. And if we end up here, we'll make these truthy. So just so we will count them once and not multiple times. And then we need 2 ints here, so we will have triplets and doubles, like that. And if we have gone through this and we found a double instance, we can say doubles equals, if a double instance, it will increment that. So we have an increment here, and it will be 1 if one exists and 0 if not. So that makes it increment if it has a double instance, and it will not increment if it doesn't. So we take triplets here as well. So now we have counted the triplets and the doubles, and we can do an output here, system out, print line, and here we need, let's just do the actual calculation here, like this. So now what we have done is that we have gone through, fetched each line in the input. We have created a char array for holding the specific line counting of the chars. So this will hold the actual number of instances of one char in that line. We will fill that with 0. We go through the line from 0 to the length of the line. We get each character in the line of text. We check for that instant inside of our alphabet, and we will get a number position. And that number position in the char array we will increment. That means that we will count how many times a specific char appears inside of our line. When we have done that, we'll go through these number instances and see if any of them are exactly 2 or 3. In that case, we'll set booleans in order to see if we have a double instance or a triple instance. We will increment the doubles and triplets if we have an instance of them. So we'll only count doubles and triplets once. And lastly, when everything is done, we will multiply these. And this if everything goes right, and if we have thought this out, we will get the answer for the first. Otherwise, we need to go through this again and try to figure out where we thought wrong. So this says 4,920. That's a large number, but I'm pretty sure of it, so we'll try it. And it was the right answer. So we read through it, we figured it out, we made some code. I hope that code was pretty clear and pretty easy to follow. And we also ended up with the correct answer. So now, this is number 2, the part 2 of this puzzle. Confident that your list of box IDs is complete, you are ready to find the boxes full of prototype fabric. The boxes will have IDs which differ by exactly 1 character at the same position in both strings. For example, giving the following box IDs. Okay, so there we have pretty much the alphabet, or we have a lot of different. The IDs A, B, C, D, E and A, X, C, Y, E are close, but they differ by 2 characters. The second and fourth, however, F, G, I, J, H, J and F, G, U, I, J differ by exactly 1 character. And the third, H and U, see here, the fourth and the third H and U, those must be the correct boxes. What letters are common between the 2 correct box IDs? In the example above, this is found by removing the differing characters from the ID, producing F, G, I, J. Although it has changed, you can still get the puzzle input. Okay, so we need to check all the inputs with all the other inputs and find inputs that only have a difference of 1 letter in the input. So the easiest way to do this is to actually use a Levenstein, which will look for the smallest number of changes in an actual set of numbers. So it will count the difference between each line and then give the result. But we still need a Levenstein that checks all the box IDs. And I think that as they only should differ by exactly 1 character, I think we can go through and accept 1 character in each line differing, but if we find 2 characters, we will discard that combination and continue with the next one. So we can be a little bit more efficient than going through and checking every one of them, hopefully. So let's try that out. I may want to do a day 2B here, because I think it can be a bit much to actually figure this one out. I don't believe we need the alphabet at all. We don't need to count anything, and we pretty much don't need anything of this. We might want to keep the going through the line part here. So, like that. And I also think that we want to put this outside of here, and we actually want to have a string list, a listicles of strings, all the strings, and like that. and this is an array list, like that, and we end that. And I believe that we last time figured out that we couldn't have just like this. We need to actually tell it that it should be strings because of the low version number of Java. But it's pretty good to actually code for older versions of Java, because then you can actually code anything. If you use the new features, it will only work on the newer versions of Java. So if you are doing something old, Java is always backwards compatible, so you can actually reuse code that is pretty old, which is very nice. So now we can go through here and we can actually do some iterators. So let's do an iterator. HTML iterator. No, thank you. An iterator, and I think it's Java util iterator we want. And this should be the iterator number 1 of the all the strings iterator. And then we have iterator IT number 2, which is all the strings iterator number 2. Why I do this is because I want to do this while the first iterator has more, and I also want to do it while the second iterator has more. And in the outer loop I will tell it to look at the next, and here we have string line 1, and I thought next, yeah, we didn't say that it was a string iterator. Of course we want it to be a string iterator. So if you don't tell it what type it is, it will actually be objects, and that makes things a little bit more sad. You don't want that. So that is what we want. So now we can go through here and take line 1, and that will get char1, and we can take line 2, and that will be char number 2. And chars can actually be checked like this. If char1 and char2 is not equal, then we will do something. And what will we do? Up here we will see we will have a boolean found difference, and it should be false. And if we go here and this is the case, we will have found a difference. And so that's true, but we also need to check that found a difference is not true. Else, if we get this C1 not equal to C2, and that means that we found a difference, but we already have set the flag. Maybe we can do this a little bit less convoluted. So if we find a difference, we will check here if we already have found a difference, like that. Then we will see here, continue with this part up here. And we also need this iterator to reset up here. So then we don't need to set it up here, because if we have gone through and checked the first line of everyone, then we want to go through and check this, the second line with everything. So that we need to reset our iterator in the inner while loop. But we also need here to have some label on this while loop. Let's say what can we call this? Second line while. Let's do that. And we say here that we continue with the second line while. So this is because if we say continue here, the for loop will try the next one. And that's not what we want. And if the for loop actually comes here, and we have ended up that, let's see here, we found a difference, but in other cases we will have actually continued with the next line and so on. So will have jumped out. But if we have come here and found a difference, then we have found our two strings. So then we will wait a minute, we can do like this as well. No, we can't. My thought here was that I actually wanted to tell it what character was the difference. But as we can have more than one character which is the same in the line, we might remove the wrong character. So we actually need to figure out where the difference is. So we need to do another loop down here, and we need to take both of these, and we need to have the difference here, like that. And actually, if these are the same, so if I have a string, correct box ID, we can call that. So that's what we want. And here, as we don't look at performance at all, we can just add to this. In some cases, when you're using older Java, you want to use a string builder and so on. When you are iterating and adding a lot of strings, then string builders are good for environment when you're working in one thread. And string, let's see, a string builder, and there are two of them. One of are good in threaded situations, and one of them are good in every other situation when you have multiple threads. And I have a video on that as well, talking about different string interpreters. So here we will actually add character to that. Could that be a good solution? And then we will want to just end up typing out the correct box ID down here. But we can create it up here because this will only be done once. Because well. We can do this trick again if we like, and I feel like it. Or otherwise I could make a function and do this really nice and tidy. But as we're doing it fast, I will have a first line while. So I will name that as well. And down here, when we are done with this string, we have gone through the for loop, I will break this while loop. So I will end up printing out the correct result. So let's see, what did we do here? We started up by creating some reading, a buffered reader, and we created a list of all the strings. And then we populated that list from the file. We created two iterators that we wanted to use in order to go through the line both 2 times and make it in a way that we can actually check every line with every other line. Then we needed a string for the correct box ID that we will use in the end. we wanted to give the while loop an actual ID, so we can, or a label, so we can actually break to it or continue from it. And this while loop will go through with the first iterator every string, and we will get the next as line 1. We will create a new iterator for this all strings that we will use for the second line. So we go through everyone with one line and then everyone with another iterator. So the inner loop will go much faster, and then the one outer loop will go once in a while. And then there's while loop for the second iterator. We set differences to false. We will get the second line. And then we have our for loop here, where we get a character from each line at the same position. We will check if these are different. And if we have already found a difference, that means that we found two differences in one line, and that we don't want. So then we will continue with the next in the iterator. And if we didn't do that, then we will set that we found a difference. And this for loop will probably most of the time hit this continue line, so we will not end up here if we haven't a situation where only one letter is missing. And if that is the case, that we only have one letter that is different, we need to go through the lines again, and we will look at the first line and the second line at same position, and if they are equal, then they are a part of the correct box ID, so we will add that character in. If not equal, we will not add it, and that will probably only happen once. And when we are done with that, we want to break this outer loop as well, this outer while loop. And that means that we will end up here with our system out the correct box ID. And if we want, we can actually just do like this and then do a system exit as well if we want, because we don't want to run this anymore when we are done. We just want to get out of there when we have found the right one. And now we have a null pointer exception. So somewhere we have missed something. So a null pointer exception on that line. Yeah, because line is not defined. We need to look at line 1. So let's try it again. We have one more null pointer because we have one more loop. Of course. And there we have the finished string. So this should be the result for my inputs. So if you are running this yourself, then you probably will have a different input file and you will need to try something different. So let's try to submit this and see if we got the right one. We got the right answer. So now we have solved the day 2 puzzles as well. They weren't particularly hard, but I think that I needed to actually think about them some, and I hope that I conveyed how I actually came to the solution so you could follow along in a good way. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.